In this video, I'm going to go over plotting ordered pairs and graphing by plotting ordered pairs. Now, we use the Cartesian coordinate system. That's what it's called. Probably named after some mathematician. And in the Cartesian coordinate system, you might need to know the different quadrants. Now, we have quadrant 1 here. Quadrant 2, we go counterclockwise. Quadrant 2 is over here. Sorry for the Roman numerals. But that's how they label the quadrants. Quadrant 3 here, and quadrant 4 there. You go counterclockwise. Now, why do we need to know the names of the quadrants? Well, there's certain characteristics about each quadrant, and if your ordered pair has those characteristics, then you know which quadrant you should be in, and you kind of be able to check your answer that way. So I'll just take any random point. This is how we write ordered pairs. We have parentheses, number, comma, another number, and parentheses. Now, first number is your x coordinate. What x coordinate? This right here is called the x-axis because it tells you where you are horizontally. Okay? And this other number is your y coordinate. That tells you where you're at vertically. Using the y-axis. There. So the first number is 3, and it's a positive 3. This is the positive direction. Right? Downward is a negative direction. To the left is a negative direction. Upward is a positive direction. That's very important to know. Usually you just need to label the first couple numbers when you're drawing the Cartesian coordinate system. Just label the first couple numbers so that your professor knows what your intervals are. Sometimes you can use 1/2 and then 1, 3/2, 2, It's really based on what you're graphing, the ordered pairs you are given. Sometimes you'll be given fractions. Sometimes you'll be given very large numbers and you might want to count by 5s. 5, 10, 15, 20. Might be better for you. Anyway. So our x-coordinate for this particular ordered pair is 3, okay? And the y-coordinate is -2. So we go to the right, 1, 2, 3, and we go down 2 because 2 is negative in this particular example. So we go down 2, 1, 2, we're in the -2 and the 3 line up is our point. 3, -2. It's that simple. That does not look like a comma. Anyway. Now, what if we had a point just 3, 2? Well, Positive, positive. Okay, so 1, 2, 3. And we go up 2 this time. 1, 2. 3 into 2. Zzz. I should also mention that this is called the origin, and it is the ordered pair 0, 0. I don't think it falls under any particular quadrant, but you might want to Google that. I mean, is 0 a positive number? Maybe. But anyways, let's continue. Let's try -3, +2. What do we get? Okay, well, -3. Well, now on the x-axis, we got to go to the left because this is the negative direction. So 1, 2, 3, +2. 1, 2. Zzz. That's our point. And what if both are negative? -3, -2. 1, 2, 3. Go down 2 to -2, right? That is all there is to it. Now, why did I just plot those numbers? To show you what a difference it makes just by changing the signs. All we did was change the signs. We used 3 for the x and 2 for the y the whole time. All I did was change the signs. We got 4 different points. So signs matter. Now, how can we know if we did it right? Well, if both are positive, then we should be in quadrant 1. And we are. If x is negative and y is positive, we should be in quadrant 2. Let me just write x, y here. If both are negative, we should be in quadrant 3. And if y is negative, we should be in quadrant 4. See that? That's how ordered pairs work. You should be able to plot whatever ordered pair you're given. Let's just say 5, 1, 2, 3, 4, 5, 1, boom, right there. 5, 1. -3, 0. Okay, 1, 2, 3, 0. We don't go up or down, we just stay right there. -3, 0. I could give you a bunch of examples until this whole board is filled up with dots. So let's just do one more. -1/3. Okay, well, -1/3. I was going to do 1/2. -1/3. +3/2. What? Okay. Well, I guess we just kind of see if we can divide this into thirds. We go left 1/3, and then we go up 3/2. How many is 3/2? That's 1.5, right? 1.5. Be about there. Maybe a little more to the right. But either way, your professor will give you credit for that. That's how plotting points works. All right, now this is the second part of the video. We're going to go over graphing by plotting points. Now, this is a function, and we're going to go over the properties of functions in later videos. This is a very simple one, and we're just going to go over the the easiest way to graph it. Well, maybe not the easiest, but the most surefire way to graph something is to just substitute values for x and see what comes out the other side. This is an input, and this is your output. That's what a function is. Now, when we do that, we're going to get ordered pairs. Now, we already know what the x-coordinate of those ordered pairs are going to be. So the first one's going to be -2, comma something. And then we're going to have -1 something, 0 something, 1 something, and +2 something. We don't know what the other thing is because we haven't figured it out yet. By the way, just label this 1, this -1, -1, 1. Okay. And maybe label this 2, just so you know the intervals that we're going here. Okay, so what do we do when we substitute? We take this and we substitute in our number for x. This is why it's called a variable, because it varies in value. So we have 3 times -2 minus 2, this whole thing. Got to include the whole thing. So 3 times -2 is -6 minus another 2, -8. So we have our first ordered pair, -2, -8. Now, do the same thing with -1. Three times -1, -3 minus 2, -5, right? All right, same thing with 0. 3 times 0 is 0, minus 2, -2. Same thing with 1. Same thing with 2. 3 times 1 is 3, minus 2 is 1. 3 times 2 is 6, minus 2 is 4. And when you look at that, these go up by 3 each time. Isn't that interesting? There's a 3 right there. We'll get into that in later videos, but there are faster ways of doing this. Anyway, -2, -8, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Whoa, all the way down here. Try and line that up. There we go. There's our -2, -8. -1, -5. 1, 2, 3, 4, 5. Right there's a good spot. 0, -2. Well, 0 means we don't move left or right. We just go down 2. We're right on the y-axis there. Interesting. If you're on the y-axis, x will be 0, always. And vice versa. If you're on the x-axis, then y will be 0. Okay, 1, 1, right there. 2, 4, 1, 2, right. Well, now what do? We kind of eyeball it, try and connect the dots in a perfect line. It connects alternate. Well, okay, not so perfect line, but you see the point. This function represents a line. No matter what value you put in for x, if you put in every single value you could possibly think of, all the different fractions in between 1 and 0, you will get all these numbers for all along this line. And you'll go on forever. All the different values of x, and it'll keep going on forever. That's why we put an arrow, because it goes on forever. And that's why we put a line, because we need to fill in all those different points in between each number, each of the whole numbers. We have very small numbers in between all these too. And all these fractions, we don't want to deal with fractions. Only whole numbers for us. Or integers, I should say. Forgot my lesson 1. And that's how you graph, by plotting points. Substitute values in for x, get your y value, and you use that to make ordered pairs. 1, 1, 2, 4, and so on. Thanks for watching.